Well, liquid nitrogen is wonderful for demonstrating various aspects of physics. The motion of molecules and changes in states of matter. So we use it quite a lot at Cranbrook Institute of Science, and we're really very grateful to Michigan Gas for being so interested in education and helping us out in obtaining the liquid nitrogen. To make ice cream, of course, what we do, we have a special recipe that's available online. It's a Ben & Jerry's recipe for ice cream. But it's a mixture of whipping cream and half, some sugar and a little vanilla extract. And you can add other things like strawberries or chocolate chips and things like that. So once you've got the fluid in the right proportions, then we slowly add liquid nitrogen to it. And then continuously stir it so that it doesn't freeze into a solid lump. The bubbling nitrogen gas helps keep it fluffy too, but when it finally freezes over, it's some of the creamiest, smoothest ice cream you'll ever experience. Today, we are going to make ice cream. So, what I've done is prepare this special mixture. It's a mixture of whipping cream and half, and there's vanilla extract in here and a little bit of sugar. It's actually the exact formula used by Ben & Jerry's ice cream. Anybody like Ben & Jerry's ice cream?
Yeah.
Very good, very good. And let me ask a question. Is it okay for everyone to have chocolate? Excellent. I'll make chocolate chip vanilla ice cream here today. So I'm going to put the ice cream mix in here. And the nitrogen is going to freeze it up for us. I'm going to be stirring, and don't be alarmed. You'll see all sorts of nitrogen gas coming out and pouring down over the table, but we'll be very careful here. In fact, I'm going to put some goggles on because I'll be right over the fluid, and I don't want any to splash up onto my eyes. So I've got my specially designed wood spoon here. So are we ready?
Ready.
Okay, very good. Excellent. I'll just go ahead then and put the fluid in. Excellent. Okay. Wonderful. And I'm ready to start. We'll just start off using what I had in here. I'll pour it in there. And then the key is to keep stirring. Very good, very good. Now, if one of my assistants off-site here, could you please help me out by slowly pouring some of the liquid nitrogen in there? Nice and easy. There you go. Okay, let her rip. Very good. Excellent. Good job. This is excellent stuff here. Does it smell like ice cream? Okay. Now, one of the key things is to keep stirring. That way it doesn't turn into a frozen lump. Okay, let's have a little more in there.
Obviously it's
Very
safe to
good.
eat that.
Oh yes, absolutely. There's nothing bad going on here. All of the nitrogen is going to bubble away into gas. So none of the nitrogen is even going to be left. Okay, very good. How about a little more there, please? Getting close. Okay, very good. Okay, excellent, excellent. And now for some chocolate chips in there. And what we have done, you guys, is to make Ben & Jerry's chocolate chip ice cream. So it has many practical uses as well. Perhaps one of the more important ones is surgery, cryosurgery. Dermatologists, of course, use it to remove skin cancers and other growths on the skin, but it's also used internally for surgery as well. It is used to strip paint off of cars, for shrinking bolts and making tight fits. In airplane technology and also in dyes and things like this, tool and die industry. And of course, lately these days, we inflate tires with it as well. Yeah.
Oh, man.
There you go. One for you.
What
do. Now, in terms of a really neat, easy demonstration, in terms of states of matter, You can take a balloon and immerse it into the liquid nitrogen and slow down the motion of the molecules. You actually freeze the air inside into a couple little crystals. It's 320 degrees below zero. I'll show you what would happen to our atmosphere if it was 320 degrees below zero outside. No, you don't have to hold your ears. It's just the opposite. We're slowing down the motion of the molecules in the air. They're getting close together and collapsing. About 16 pounds per square inch is bearing down on these balloons. I could probably put about 20 balloons in here. I'm being very careful right now not to get any of the fluid on my skin. All right, and now when I bring them back out into the atmosphere, and the warmth in the room, the molecules will start speeding up, and it'll start slowly re-expanding, coming back to life. The molecules are going faster and faster, and re-expanding. So there's all kinds of neat principles of physics that we can demonstrate using these really, really cold conditions. We could, for instance, take a racquetball or a tennis ball and immerse it in the fluid, and then drop it on a nice hard concrete floor. And listen to it bounce.
Oh!
And we can also do the same thing with something like a flower, very delicate. Freeze it completely and shatter it with one stroke of a hand. Just very brittle, chips apart.